Moving into section 2 of chapter 6. Remember, we're still talking about the periodic table and periodic law. We are in section 2, classification of elements. Okay, the objectives for this section: explain why elements in the same group have similar properties, identify the 4 blocks on the periodic table based on their electron configuration. Remember, we did this in chapter 5. Our review vocabulary: valence electron. Valence electron are the outer shell electrons, so the electrons in an atom's outermost orbitals or shells determines the chemical properties of an atom. Remember, these are the ones that are involved in the chemical reactions. Main idea for this section: elements are organized into different blocks in the periodic table according to their electron configurations. Okay, recall that electrons in the highest principal energy levels are called the valence electrons, the ones in the outermost shell, the ones that are furthest away from the nucleus. We went through your periodic table and labeled each group as to how many electrons there are in each of those elements. So remember that group 1 elements have 1 valence electron. They'd like to lose 1 to get to group 18 to be a noble gas. Okay, the high energy level of an element's valence electron indicates the period on the periodic table which it is found. Remember, a group is the column, period is the row. So the number of valence electrons for an element in group 13 through 18 is 10 less than their group number. So if you look at the periodic table that you wrote on, you can see group 1 has each element in the group has 1 valence shell, or 1 valence electron, 1 electron in its outer shell. Group 2, remember, these are the alkaline earth metal, or these are the alkali metals, these are the alkaline earth metals. These guys have 2 in their outer shell. Jump over, remember, we're skipping the transition elements for now. Going to group 13, this is what they're talking about. If you subtract 10 from these numbers, you will see 3 in their valence electron. This group has 4. This group has 5. This group has 6. This group has 7 in their outer shell, their valence electrons. These guys are full. Remember, they're content. They're happy. They have 8. Remember, this guy only has 2, but he's still a noble gas because he only has 1. He only has the s orbital to fill, so he is full. Now, the periodic table, the shape of the periodic table is basically broken up into these blocks, and we've talked about this in chapter 5. So if you divide it into blocks representing the atom's energy sublevels, you can see how the valence electrons are filled. So remember, groups 1 and 2 are the s orbitals. Then you're going to jump over to the p's, right? You're going to fill the s's, then the p's, and you can see the purple are the p's. Then you're going to be down at 1, 2, 3. We're going to be in period 4. We're going to start filling the d's. Then we're going to fill the f's. Now remember, s's can hold 2 electrons. P's can hold 1, 2, 3, 4, 5, 6 electrons. D's can hold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. And the f's can hold 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 2, 6, 10, and 14. Okay. The s elements consist of groups 1 and 2 and helium. Group 1 elements have partially filled s orbital with 1 electron. Group 2s have completely filled s's with 2 electrons. Okay, so after the s orbital is filled, the valence electrons then move over and start filling the p orbital. Groups 13 through 18 contain elements with completely or partially filled p orbitals. Now, I would suggest you go to glencoe.com if you're having a hard time with this electron configuration, because this is a really good interactive tool to help you remember how to do that. Okay, now we're going to move down into the D block. The D block contains the transition metals, and the Ds are the largest. Okay, there are exceptions. Remember, there's always exceptions to the rules. But the D block elements usually have filled their outermost s orbital and filled or partially filled their d. So remember, there's a couple that we had talked about where the s is filled before the d or the d fills before the s. It just depends on that specific element. 5 d orbitals can hold up to 10 electrons. So the D block spans 10 groups on the periodic table. Now we're going to move down to the F block. Remember, those, the lanthanoid and the actinoid series, are called the inner transition metals because we move those up in to the middle of the transition elements. So the F block contains the inner transition metals. F block elements have filled or partially filled outermost s orbitals and filled or partially filled 4f and 5f orbitals. The 7f orbitals hold 14 electrons, and the inner transition metals span 14 groups. Okay, which of the following is not one of the elemental blocks on the periodic table? S, D, G, or F? The answer is G. Okay, which block spans 14 elemental groups? S, P, F, or G? Right, good job.